Hi everyone, my name is Ifomoko and I'll be presenting our paper, the Igbo API Dataset, Empowering Igbo English Language Technologies through Multidialectal Enrichment. So this paper is about an Igbo API dataset which we created, and it's a multidialectal Igbo English dictionary that was designed to foster the development of Igbo language technologies. We conducted two experiments to show how important this data set is. And throughout this presentation, you will see these experiments. The motivation for this was looking at the recent technological advancements that is surrounding language technologies. We see that Igbo language in particular, the language technologies that are being built around it are solely focusing on standard Igbo, which does not fully represent how richly diverse the Igbo language is. The Igbo language is rich in different dialects, which is unique for different regions and communities. And the challenge is that different speakers tend to write in a manner that reflects their specific dialect. And if we use an example of a machine translation, you see that if the recent language technologies translate sentences that are in dialectal Igbo, it doesn't give an accurate result. So our objective was to create a multi-dialectal data set and then conduct two experiments to show how important the data set is. So looking at the data set was created by expert lexicographers who sourced these Igbo words and the example sentences. The words were all from 33 distinct Igbo dialects, and it contains 5,000 Igbo words, the 17,000 unique dialectal word variations, and 27,000 example parallel sentences of these words. So for each word, it has like different example sentences. This is an example here. So number one shows Nwoke, which is an Igbo word that is part of the 5,000 words I mentioned earlier. And number two shows the pass of speech that this word is. And for every word, we have the English translation, which is number three. For Nwoke, it means man or boy. And number four shows the example. So for each word, it has different examples. Some of them have just one example, and some of them have up to 4 examples. And for each example, it has an English translation. And then number 5 shows the related word for this. So for example, 1 means girl, which is like a related word for boy. And number 6 shows the word stem. And then number 7 shows the dialectal variation, which is one of the important things in this data set. And at the right-hand side, you will see like the different dialectal variations of Nwoke. So each of them from different dialects. So Ngwa is a dialect, Nsukka is a dialect, Onitsha is a dialect. And for each of these dialects, they pronounce Nwoke different ways. So after collecting our data set, we started conducting experiments. And this experiment we did was to demonstrate the distinctive value of this dialectal data set and how important they are. And you will get to see the outcome and the insights we got from there. Number one is the semantic lexicon. So we know that semantic tagging provides a structured way to perform automatic semantic analysis for text, which can be valuable in diverse fields, for example, in information extraction. And one of the challenges we face is lack of semantic tagger for Igbo language. However, having this Igbo API dataset, we are able to have the opportunity to build an Igbo semantic lexicon, which is a critical resource when it comes to creating semantic tagger. In creating this, we had to speed up the typically costly and time-consuming process of creating a very comprehensive semantic lexicon. We use a bootstrapping approach that leverage the multi-dialectal structure of the Igbo API dataset, and we applied the existing semantic tagger from PYMUSAS, which is a system that offers multilingual semantic tagging. The method that we used was to leverage the word classes in the Igbo API dataset, which is similar to POS tags. So with all the 5,000 words that we had, each of them has these POS tags, and we aligned it with the Masakene POS tag set, leading to a cross-referencing of 176 co-occurring words that served as the foundation for our lexicon bootstrapping process. So this is our bootstrapping process. So in our process, we identified from the Masakene data set, we identified top non-functioning function words and their most frequent POS tags. And then we cross-referenced it with our own data set to find a match. So if there is no match between the two data sets, we drop that entry. But if there is a match, we manually assign the USAS semantic tag to those words, while simultaneously also using PYMUSAS to automatically assign the semantic tags to the English corresponding definition, allowing us to be able to evaluate the accuracy of the automated process by comparing its results with the manually assigned tags. In our results, it clearly shows that with minimal effort, it is perfectly possible to use our data set, which is Igbo API data set, to bootstrap the creation of the Igbo semantic lexicon. It can be observed that even with the distributed evaluation scheme, the top one, the automatically generated tags correspond to with the human annotated humanly assigned tags about 50% of the time, which is good for its potential. The second experiment we did was the machine translation experiment. So looking at the recent machine translation, Igbo to English machine translation models, we see that it doesn't really capture the Igbo dialect very well. And we started asking ourselves, how do we improve these machine translations to actually inculcate the diverse Igbo dialects? An example would be from this chart. You see that for the standard Igbo, we have a dialectal variation of Sonyere and Sonyelo. And in standard Igbo, Sonyere is the standard Igbo. And in this sentence, it got the correct translation based on the human evaluation. But when we add the dialectal variation, it gives a wrong translation. And this shows how important it is to actually add all these dialectal variations in our model. So the methodology we used, the first thing we did was to do augmentation. So in augmentation, why we did this was to actually add the dialectal variances in the sentences. So our data set contains just the words, the example sentences, and these example sentences we are from the head word. And then it also had dialectal variations, but the example sentences we are not added to the dialectal variations. So what we did was to create a synthetic sentence from these example sentences so that it has these dialectal variations. And these sentences are exactly the example sentences, just changing the dialectal variation with the head words. When we finished this, we added these synthetic sentences to the original data set, and it created a larger final data set, which we shared into two. So the first one was the unseen dialect test set. This was just 7 unseen dialects we brought out, and this was because we wanted to make sure that our fine-tuned model is generalizing very well and is able to see a sentence and actually know that this is just a dialectal variation and not just a different sentence entirely, just like the example we saw from here. And after we've brought out these 7 unseen dialects, the remaining data set was created randomly through the 80-10-10 split. And the second test set there was now used as our second validation data set. So the model that we used was the M2M100 Igbo to English model. This model was fine-tuned
on the state-of-the-art M2M100. So we use this model because at this moment, it was the best it has high translation quality when it comes to Igbo language because it has already been fine-tuned using an Igbo data set. But the issue is that those data sets were in standard Igbo. And because of that, it was not able to reflect the dialectal variations. And then we fine-tuned our data set on that model. And we used the BLUE and the TR scores to measure our translation quality. So from our results, we observed an improvement of 55 plus for the standard test set, and then 51 plus BLUE score for the unseen data set. Looking at this, you will see that the unseen dialect test set performed worse than the standard one, showing you the challenge these models have when it comes to dialectal machine translation, emphasizing how important this data set is in this field. And if you look at this, you might think that the BLUE score are too high. And wondering on what could be the reason, we tried to look at our result again by doing an ablation study. So this study we conducted by trying to investigate the effects of this dialectal infusion in our fine-tuned model to actually detect whether truly these dialectal variations are important or actually affect the model, or if maybe something else is affecting our model that is giving it this high score. So what we did was to separate our data into two. This sub data set was for the data set with fine-tune with dialect and the ones without dialect. So what this means is that the one with dialect are all the synthetic sentences that we created by ourselves that contains those dialectal variations. And the ones without dialect are the original ones that do not contain the dialectal variation at all. And using the same settings that we conducted the earlier experiment, we conducted this experiment, fine-tuning it on those models to see the result. And looking at the results, you will see that the fine-tuned model with the dialectal data set performs better than the ones without the dialect. You might say that the score might seem marginal. The BLUE score is marginal because it's just +4 BLUE score higher than the one without dialect. But looking at the table below, you will see how important using the model that it has a dialectal sentence and the one that has non-dialectal affects the result of the translation. For example, kokota is a word that says call together. If you look at the prediction when you are using the model that we fine-tuned with dialect, it gets the result correctly. But looking at the one without dialect, it gets the word wrong. And this same goes with the remaining Igbo words. So with this result, you can see that having a language model that contains a dialectal variation is important when it comes to machine translation for Igbo language. So in conclusion, we'll see that the creation of the multi-dialectal data set is an important data set for this study. And we are able to create a benchmark machine translation model that understands this dialectal variation, and we are able to bootstrap the creation of the Igbo semantic lexicon. You can check out our paper data set here and play around with it. Thank you.